This video deals with the green chemistry. That is the basic principles of green chemistry. There are 12 basic principles of green chemistry I'll discuss in this video. Before that, I'll consider what is green chemistry. So the green chemistry or sustainable chemistry is the design, development and applications of chemistry or application of chemical product and process that to reduce or eliminate the use of and the generation of hazardous substance to human health and environment. That is, we have to choose a sustainable way to design or to develop and their applications of chemical product. So in the medicinal field, we use a large quantity of, we'll produce a large amount of products. We use or we'll synthesize the product. And during the production times, there is a huge amount of hazardous materials will introduce to the atmosphere, and even the some amount of genotoxic or the toxicity, the side formed product that will affect the human body, side effects that may cause. See, in the development of green chemistry, results reduce the or eliminate the hazardous substances that formed, that we have to reduce the cause of this hazardous chemical to the human health and the environment. And the entire thing we'll consider as a green chemistry. It's a sustainable chemistry, is the design, development and application of a chemical product and process that to reduce or eliminate the use and generation of hazardous substance to human as well as environment. As a chemical philosophy, that green chemistry applies to all kind of chemistry, like it may apply to organic chemistry, physical chemistry, analytical chemistry, biochemistry, and even for inorganic chemistry. The main idea of green chemistry is to enhance the production efficiency. It should just to increase the production efficiency. Yield of the product should be increased. Then we have to minimize the waste generation. So during the product formation, chemical compound formation, we use a lot of solvents. That solvent is then it is washed with another organic solvents or with the water, ice cold water like. So that time these components we introduce to the or will directly dump into the sink. So waste content increases. So by using green chemical method, we can minimize the waste generation during the production and maximize the efficiency and utilization of renewable source. These are the basic things included in the green chemistry. Now, I am coming to the 12 basic principles of green chemistry. The basic principles of green chemistry. The first and foremost principle of basic principle of green chemistry is a prevent waste. Then second one, I'll discuss one by one. Prevent waste, maximize atom economy, less hazardous chemical synthesis, safer chemicals and product synthesis, safer solvent. We have to consider or we have to use a safer solvents and reaction conditions. Increasing energy efficiency, use renewable feedstocks, avoid chemical derivatives, that is a protecting group formation, all those things we have to reduce. Then use of catalyst, design chemicals and products to degrade after use, analyze a real time to prevent pollution and minimize potential for accident. These are the 12 basic principles of green chemistry. Let us discuss one by one. The first one and foremost is pollution prevention. Prevent waste. See, while designing a molecule or designing a chemical synthesis, we have to prevent waste. That is formation of derivatives or a byproducts or the solvent we have to reduce. Leave no waste to treat or clean up. And you know the traditional method, in the traditional method, we normally use a condenser, heating in a RB flask, long-term heating for about 12 to 24 hours, 6 to 12 hours, like a long-term heat or even 2 hours of heating. Then after that, we'll separate the products. Separation is required, purification is required. So like the stepwise, we'll carry the process. During this process, if plenty of waste of things will introduce to the atmosphere. See, if you reduce the use of these chemicals or the waste, then we can introduce a less pollution to the atmosphere. So that is the basic criteria of green chemistry, that is a pollution prevention. We have to design a chemical synthetic method to prevent waste. There should not be any waste or cleanup process. We should directly get the product, or within a 1 or 2 steps, or using like water, less hazardous chemical, we have to we have to get the product. We have to take care of that, prevent waste. Then second one is the atom economy. The synthetic methods should be designed to maximize the incorporation of all the materials used in the process that come or that should reflect in the product. So we have to take care no waste of atoms or a waste of few atoms. The atom economy is a measure of amount of starting materials that end up as a useful product. Like if you take an atom A, it reacts with another molecule, a molecule A reacts with a molecule B that gives the product Z. Along with this, or this process I shown it in a single step, the same process may take place with a multiple step. Okay, so here a molecule at weight, if it is 100 and the B molecular weight is 50, then the product weight, if it is 150, it is fine. That is, end up with the useful product which contains the same quantity of atoms. See, here I use 2 red atoms, 2 blue atoms, 2 green atoms, 1 blue atom and 1 black atom. See, all these atoms are reflected in the product. That means their atom economy is very high. That means it should reflect. There should not be a loss of any atom during the production of a compound. So we have to take care that should maximize the atom economy. That is, atom economy of a chemical reaction is a measure of the percentage of the reactants that becomes useful product. Say, synthetic method should be designed to maximize the, we have to take care that should maximize the incorporation of all the materials used in the process into the final product. Then third is less hazardous chemical synthesis. The product A plus B giving rise to Z product, and this should be less hazardous one. The product should be less hazardous. So it should not impact or toxicity to the human being or the environment. So it's not possible 100%, it's not possible to achieve 100%, but whenever practicable, whenever it is possible, synthetic methodologies should be designed to use and generate a substance that possesses little or no waste or no toxicity, little or no toxicity to human health and the environment. That's how we have to take care of that. Fourth one is designing safer chemicals. A chemical product should be designed to preserve efficacy of the function while reducing toxicity. There should not be any toxicity in the molecules, but their efficiency is very high. Okay. Then fifth one, safer solvent and auxiliaries. For some reactions, we need some reagents which is not directly interact with the reactant molecule, but to carry that reactions, we need that type of reagents, solvents, separation reagents, or even to recovery that product, we have to introduce some solvents. See, while choosing the solvent, we have to choose a safer solvent that should not be impart any toxicity or it should not be any carcinogenic in nature. So the use of auxiliary substances like solvents, separation liquids, or even any other components, reagents itself, some reagents should be made unnecessary whenever possible, and when used, we should use in conscious. We have to minimize the dangerous components. We have to use a safer solvent. Design for energy efficiency. See, most of the reactions we carried out at very high temperature, very high pressures in a conventional methods. But in the green, while considering the green chemistry, we have to choose an alternative path which can able to give the product in alternative path, it can able to give the product with a less energy or less temperature or pressures. See, energy requirement should be recognized for their environmental and economic impact and should be minimized. We have to consider that reaction should be economic one, and the develop a synthetic method should be conducted at ambient temperature and pressure. There should not be very high temperature or should carried out at ambient temperature and pressure, because to maintain that pressure and temperature high energy is required. See, if you carry the same reaction in an ambient temperature, we can design the product with the by considering the energy efficiency. Then use of renewable feedstock. See, always it's not possible to use a renewable feedstock always, but whenever it is possible, we have to use a raw materials or a feedstock that should be renewable rather than depleting whenever technically and economically practical. See, like while getting the product, we have to take care of all the 12 concept or a basic principle, and need not to obey all the 12 basic principles. Some principles may be obeyed, but some it's not possible to achieve. But whatever is possible, we have to achieve. So seventh one is use of renewable feedstock. If you use a renewable feedstock, there is no loss in the feedstock. See, in the manufacture of ethanol, we normally use a sugarcane juice. It's a renewable one. We can get it in a large axis. We can cultivate. It gives the work to agricultural land, or it gives the farmers work to farmers. They cultivate sugarcane, and that sugarcane from that we can get a sugar, and as a byproduct is a molasses, and from that we can get the ethanol. Like it is sometimes like it looks like a renewable energy, feedstock. That type of, we have to choose that type of feedstocks. A raw material or a feedstock should be renewable rather than depleting whenever technically and economically practical. Reduce derivatives. See, sometimes the product is formed with a long path, like instead of getting A to E, so it is not possible to get in one step. That time we have to follow a large step. A may react with Z molecule forming B, and then that B molecule may react with Y molecule producing C, and C may react with X plus W molecule forming a D, like see different, and finally that D on reaction with the U molecule produces E. So it produces lot of derivatives. Say as a result, there is a loss of energy. Okay. Say unnecessary derivation should be avoided whenever possible. Say like temporary modification, physical change, chemical. This is a steps formation, or you may be blocked during the process. Sometimes some molecules have to block, otherwise the side reaction take place. We have to take care of that. So we have to choose raw materials in such a way that there should not be any blocking materials. We should use during the progress of the reactions. Like unnecessary derivatization should be avoided whenever possible. Then use of catalyst. In almost all reaction, if you use a catalyst, in most of the reaction, if you use a catalyst, it will take easy path. So the transition from reactant to product becomes easy, or it takes with a less energy. So catalytic reagents are superior in stoichiometric reagents. See, minimize the waste by using catalytic reaction. And again, while choosing the catalyst, we have to choose it should be biocompatible one. So like the some inorganic material, it will not degrade in the atmosphere, so in the environment. So if any alternative catalyst is possible, then we have to use that type of catalyst. Design for degradation. See, why it's not possible in all the cases, we have to design a product in such a way that that final product should degrade easily. The chemical product should be designed so that end up of their function, they do not persist in the environment and instead break down into harmless degradation product. See, x plus y giving rise to c, and the final thing that c, x plus y product that gives c, and this final c should be degrade easily in the atmosphere. See, harmless degradation should take place. See, the one product that is polyethylene. In the beginning, it becomes very popular things to carry the substance or any components. See, but nowadays that becomes the problem because we are not consider how it is degraded, when it is degraded, what is the time duration required for the degradation, and after degradation, what is the harmful component produced, or whether it is produced harmless components, we are not at all considered. So that's why, see, while synthesis a new compound, we have to take care of their degradation. Design for degradation. See, chemical product should be designed so that their end, their function, they do not persist in the environment and they should break into a harmless degradation product. The one more product like a DDTA. DDT is used familiarly, that is a familiar compound, but its degradation becomes difficult. Like, so that one is not environment friendly one. So alternative while choosing or while synthesis, while developing an alternative compound, so we have to take care of this. Real-time analysis for pollution prevention. See, analytical methodologies should be developed or it need to be developed to allow for real-time in-process monitoring and control prior to the formation of hazardous substance. See, we have to take care of pollution control, like if any product is formed, whether it is harmful to the atmosphere, harmful to the human beings, we have to take care in a real-time sense. So not after completing or after facing the difficulty, then we should not think. Before only we have to think and we have to take some solution. So real-time analysis for pollution prevention is required while synthesizing compounds. Then final one, 12th principle is inherently safer chemistry for accident prevention. While doing any product, we have to take care of accident prevention. The substance and the form of substance used in chemical process should be chosen so as to minimize the potential for chemical accidents, including releases, explosions, or even fire. Like, say, in some cases, we have to heat the content very high temperature, but we have to choose an alternative methods which can prevent the accidents, or we have to use some harmful chemicals, like, so we have to take care of this. Inherently safer chemicals should be used for accident preventions. So the substance used in chemical process should be chosen so as to minimize the potential for chemical accidents, including releases like what the component we introduced as the byproducts or the after separation some reagents we introduce. We have to use almost whenever it is possible. We have to use a safer chemicals, and we have to take care of explosion or we have to take care of fire formation. So these are the 12 principles of basic principles of green chemistry. Thank you.